Welcome, everyone, and thank you for joining the HPCC Logging in the Cloud session. As can be seen on the slide, I'm Rodrigo Pastrana, an architect on the HPCC Systems development team. I've been active on the project for about a decade now, and in that time, I've contributed to various facets of the platform, but I'm mostly focused on external tool and platform integration. I'm going to cover several topics today, which includes why component level logs are important, the challenges of managing those logs in containerized deployments, general description of external log management based solutions, a quick description of two supported log management tools. We'll do a walkthrough the process of deploying and configuring those tools for HPCC. And then we'll take an in-depth look at the new log access feature included in our ECL Watch dashboard. And finally, I'll leave you with some general log management tips for your consideration. Okay, so why component logs are important? A lot of these are obvious, but I just feel compelled to quickly go over the main reasons why log management and monitoring is important. So the most common reason we rely on logs is to identify bugs based on reported log information. We also rely on supporting information contained within those logs needed to analyze and fix those issues. Logs can help us discover inefficiencies in our workflow in order to streamline our processes. And for security and audit reasons, logs can help us track who, what, and when has been accessing or attempting to access resources or services. In short, managing and monitoring logs is instrumental in keeping software performing optimally. The major challenges of log management in containerized environments are the lack of persistency. By nature, containers are ephemeral and so are their logs. As containers are decommissioned, log loss is very likely. Accessing logs can be complicated. By default, component logs are retrievable by Kubernetes tools, which require direct access to the Kubernetes deployment. And lastly, the dynamic lifecycle of containers make it difficult to determine and locate the source of the logs we might be interested in. So HPCC follows standard Kubernetes logging protocols and standards, which allows migrations of logs from HPCC images to back-end log management services, which in turn provide solutions to the aforementioned challenges. At minimum, log management tools should provide migration of logs, log storage management, programmatic and interactive log querying mechanism, automated alerts, and other monitoring tools. There are many such tools available. We've chosen to focus on ElasticStack, which has been the de facto standard in the log management space, is open source and provides a rich feature set, and Azure Log Analytics, which is a powerful built-in tool set in the Azure portal. This feature automatically collects component logs, allows users to formulate and execute complex log queries interactively, and provides a dashboard for deployment, health analysis, and monitoring. Let's start with a brief description of ElasticStack. As previously mentioned, ElasticStack has been the de facto standard in the bare metal log management space for a long time. The stack is comprised of several previously independent components, which include FileBeats, which is responsible for harvesting and forwarding log data, ElasticStack, which provides storage, indexing, and performant data delivery. Kibana is the front-end component I depicted within the laptop on this slide. Kibana provides many tools, including index management, retention policy management, interactive querying, custom visualization, and dashboarding, and many other tools. To illustrate the power of these tools, coupled with HPCC logs, I want to share a screenshot of a work unit analysis dashboard created by Natalia Rivas, an intern with the Brazil team. This dashboard consists of multiple visualizations, which are entirely based on information reported within HPCC component logs. It contains a breakdown of each work unit's lifecycle states and timing information, which helps our team analyze their work unit performance. The point here is that we have powerful tools available to us, which allow any of us to draw critical information for analysis from our logs, not just bug information. So HPCC Systems provides an optional feature which facilitates casual users to deploy a lightweight elastic stack instance for HPCC log management. This feature can be accessed from the HPCC Helm repository and requires minimal effort to deploy and to set up. In recent versions of this feature, many previously manual steps have been automated, which greatly improves the out-of-the-box experience for the community. Once the HPCC Helm repository is available, deploying this solution is accomplished by a single command. Here's the one command needed to deploy the Elastic for HPCC Logs feature. Again, this assumes we have already added the HPCC Helm repo locally, which is a very simple process, but I also provide exact command on the resource slides. Once this command is executed, HPCC logs start to flow from each container to a newly created Elasticsearch index dedicated to HPCC logs. The logs are parsed and given structure, which gives us the ability to perform exact term queries, filtering, sorting, and output projection. Additionally, the Kibana landing page now defaults to a view tailored for the HPCC log structure. And it really is that simple. I want to point out again that previous versions of this feature relied on about 4 manual, error-prone steps to get us to this point. At this point, HPCC component logs are managed by Elastic, where we can set retention policies and view our logs and monitor our HPCC cluster. But we also want to make those logs available within HPCC. This is an optional feature, but making these logs available to HPCC allows users to access the logs directly from ECL Watch and allows the system to associate relevant logs within work unit artifacts. Mapping these logs back to HPCC is simple as well. It boils down to a single command, which provides Elastic Stack connection information and log mappings to the HPCC log access framework via a Helm values YAML file. The values file used in this example is provided in the HPCC GitHub repository. After this step completes, the logs are accessible from within ECL Watch. We'll take a closer look at this log viewer interface a little later. For those targeting an Azure cloud deployment, the HPCC provided Terraform modules streamline this process even further. The modules are available from the HPCC Systems GitHub repository under the Terraform Azure RM HPCC project. With a single command, Terraform orchestrates a deployment of HPCC on AKS with a pre-configured Elastic for HPCC logs instance. The modules do require some configuration, which is documented, and several examples are provided in the GitHub project. Okay, now let's look at Azure Log Analytics, the other log management solution we fully support. It is a built-in service, mostly accessible through the Azure portal. Azure Analytics automatically collects logs from a given AKS cluster and provides ingest and retention rules within a workspace. We're able to formulate and execute log queries and analyze them in order to identify trends, analyze patterns, and provide various insights into the Azure-based deployment. Setting up Azure Log Analytics for container log management entails creating a log analytics workspace and then linking it to a target AKS cluster. This can be accomplished either through a simple wizard on the Azure portal or via command line interface. The Azure portal wizard is very easy to use, but does not provide much flexibility. So we've provided a convenience script which automates the command line process with the added benefit of optional customization. Let's take a look at the Azure Portal Wizard first. From the AKS view on the Azure portal, we can find the logs option under the monitoring tab, which will launch the onboarding wizard. The onboarding wizard is very convenient and makes it very easy to create a new log analytics workspace and enable the monitor for containers feature on the given AKS cluster. From the pull down option, choose either a new workspace or a previously created workspace and click the Configure Azure Monitor option. Note that this feature doesn't allow the user to specify a resource group for the workspace. It forces a generic name and doesn't offer resource annotation. Also, do yourself a big favor and get acquainted with the two links highlighted above. They provide information regarding the feature's functionality, but perhaps more importantly, the pricing scheme. I will quickly mention there's reportedly no direct cost for creating or maintaining a workspace, but costs are incurred by log data ingestion and retention. For the scripted onboarding, we navigate to the Azure/logging subsection under the Helm/examples section of the HPCC source code tree, where the env log analytics file allows us to fill in several configuration entries. The user should specify their desired workspace name, followed by a set of tags to be associated with the new workspace, which is very important for resource identification and is likely required by some organizations. Also, it's very important to associate the workspace with a specific resource group, which can aid in resource cleanup and decommissioning. The user should also specify the target AKS cluster where this workspace is to be associated. Then we execute the enable log analytics script. Upon completion, HPCC logs are routed to the newly created workspace and made available via the KQL language on the Azure portal. Here's an example of a very simple KQL query, which fetches 10 HPCC component log entries. The KQL query language is extensive and provides powerful query, filtering, sorting, parsing, and visualization commands. This allows us to formulate query commands to gather the exact logs we're interested in. The log analytics feature also enables other AKS-wide monitoring functionality, which can help us stay on top of the health of the cluster and the containers running upon it. At this point, we may want to make those logs available to HPCC. So we'll provide the required connection information and log field mapping like we did in the Elastic for HPCC logs deployment. This process is, however, a bit more involved because Azure Log Analytics API requires explicit access, which needs to be procured and communicated to the HPCC Log Access Framework. To do this, we need an Azure Service Principal either created or provided to us. Depending on your Azure subscription structure, you might need to request this from your tenant owner. The Service Principal registers log API access and provides secrets for programmatic access. The appropriate secret and a couple of other bits of information must be provided to the HPCC Log Access Framework via a Kubernetes secret. It must be called Azure Log Access and contain the Service Principal client ID, the secret, the tenant ID, and our Log Analytics workspace ID. The process of creating this secret is simple and can be done manually, but to help, we've provided scripted functionality. Let's look at the Azure/Log Analytics path under the Helm/examples folder. The user should provide the information into the secrets templates files. Again, this includes the client ID, the access secret, the tenant ID, and the ID of the workspace recently selected. And now we execute the create Azure Log Access Secret script. This creates the Kubernetes secret with the 4 bits of information we need to programmatically access the logs stored in the newly created workspace. Now that we've set up the Kubernetes secret, we can configure HPCC to target our log analytics workspace by providing a log mapping values file, such as the file provided by HPCC. At this point, Azure Log Analytics is being used to manage HPCC logs, and HPCC Log Access is able to automatically retrieve those logs from the Log Analytics workspace. I'm excited to report the HPCC development team is close to completing a Terraform-based solution, which automates most of these configuration steps we just saw. With a single command, HPCC and Log Analytics will be deployed and configured on the target Azure Kubernetes cluster. Now that we're familiar with the supported log management tools and how to deploy and configure them for HPCC log management, let's explore the new ECL Watch Log Viewer, which exploits the tools provided by the log managers and exposes the logs to HPCC administrators, ECL developers, and the HPCC community at large. Let's take a look at the new Log Viewer interface, which is available in the latest version of ECL Watch. To navigate there, let's first choose the topology option on the left-hand pane, followed by the Logs tab at the top. The Log Viewer immediately pulls records from the back-end log management tool, which was configured and deployed in previous steps. As expected, the viewer allows the user to choose the number of records seen per page, and it provides page scrolling functionality. But more importantly, it provides a mechanism to filter this log set based on various criteria. If we choose to focus on logs stemming from a particular container, we can choose the container name option, where we're presented with a dynamically generated list of options based on running containers on our target Kubernetes deployment. For this example, we could choose to view all logs reported by the ECL Watch container. After choosing the appropriate term and applying, as expected, we are presented with all records reported by ECL Watch. In my example, that generated more than 1,000 records. We could further filter this down. We could choose to filter based on target audience, which can include the auditor, the operator, the programmer, or the user. We could also choose to filter down based on class, which is the log event type. They could be audit events, error events, informational events, progress, or warnings. Let's see if ECL Watch has reported any errors. We choose error and apply. And sure enough, ECL has reported one error in my instance. If instead we're interested in viewing all log entries reported for a particular work unit, we can type in the desired work unit ID in the job ID field and apply. As expected, we are now presented with all known log entries directly associated with our target work unit ID. In my example, that generated 155 log entries. At this point, we would typically want to choose the relevant log entries in order to share them for further analysis. The Log Viewer allows us to individually choose the most relevant log entries we want to share, or we could simply choose all of the log entries. We can then choose to copy the selection to clipboard, which allows us to paste that information directly into the body of an email
or an instant message, or we could simply paste it into a text file, which we could then send off to the appropriate person. The user could have also chosen to download the entire selection as a CSV file, which can easily be attached into an email, or it could be uh, opened in a more advanced CSV viewer. Let's say we want to further filter this down based on the content, the text content of the message. Let's say I'm interested in all log entries which include the output term. We can use standard wildcard syntax, where when we apply it, we are then presented with the appropriate filtered out log set. I want to emphasize that the user can and should always restrict the time window for these queries, which can easily be done in the from date and to date fields. I hope we can all see how this filtering function vastly simplifies the process of finding the proverbial needle in the haystack, which is critical for ensuring that our software is kept running optimally at all times. A version of this log viewer interface has also been embedded within each of the work unit views. So for that, let's take a look at the ECL section, and then let's choose a random work unit. From this view, we can find the embedded logs viewer from the logs tab at the top right. This view includes the same exact functionality as the general log viewer, which includes filtering, selection for copying or downloading, and navigation. It's worth mentioning that the Zap Report feature utilizes the same functionality for gathering logs and has been vastly improved both in terms of performance and in terms of the scope of the logs fetched for the package.
Okay, I hope you found that useful. We should now understand how and why log management tools should be used to manage HPCC component logs and be familiar with the graphical user interface for accessing logs from ECL Watch. At this point, I want to leave you with some general log management concepts for your consideration. First, plan. Find the best log management solution for your needs. In some cases, it's fine to relinquish your logs, but in most cases, we want to retain them for some time, monitor and analyze them. Some log management features can be surprisingly expensive. It's important to understand the price schemes and to stay within budget. Make sure you develop a log retention policy. You want to have the logs when you need them, but we don't want to incur unnecessary costs or bottlenecks. Actively monitor your logs to get a detailed insight into the state of your software. Create alerts, triggers, and other automated actions upon certain logged events to ensure speedy reaction. Limit the amount of logs to be processed by your log management tool. Not all log records are always necessary. Likewise, find the appropriate HPCC log verbosity. Find a good balance of useful log data and minimize log noise. Share this information with your team. All team members can be involved in this process and benefit from it. And of course, report deficiencies, possible improvements, and bugs found in this feature, but also those identified by virtue of this functionality. Okay, again, thank you. And before opening the floor for questions, I'll point out this slide deck contains useful resources. You can find my contact info here. Please reach out with any questions regarding this feature or the presentation. Some of the links used today are provided here. And in the last two slides, we can find sample commands, such as how to add the HPCC Helm repo and how to clone the HPCC GitHub repository in order to access some of the files I referenced earlier in the presentation. Okay, and now we'll open the floor for questions and comments. Again, thank you.